Okay, today we are going to talk about inversing exponential and logarithmic functions. Remember, we already discovered that exponential and logs are inverses of each other. So to go back to our other inverses, remember we're going to switch x and y and then resolve for y. So here we have f of x. Remember that is your y, so I'm going to make that x. And then log base 5 of y. My log and base and argument are isolated, so I'm going to go straight to exponent. So the base of 5 on that log becomes the base of the exponent. The x is the exponent, and it equals to y, and there I am. So remember the notation for an inverse is that. I won't require it, but we need to remember when we see f negative 1 of x, that means the inverse of a function, and that the inverse is a function. Okay, the next one, same thing. I'm going to take my y and make it an x. Log base 6, where the x is, I'm going to put a y. Notice that there's a parentheses around that argument y minus 4, so I can't break it apart until I rewrite it into logarithmic form. So 6 to the x equals y minus 4. Now I'm going to add that 4 to both sides and get 6 to the x plus 4 equals y, and there's my inverse. Okay, the next one, notice there's no parentheses, so it's going to be done a little bit differently than number 2. So x equals log base 4 of y plus 10. I'm going to subtract that 10 first and get x minus 10 equals log base 6 of y. Now let's convert it. So log base 6 becomes exponent base of 6 to the x minus 10 equals y, and there's its inverse. Okay, so this next one, same thing. I'm going to put x in place of the y, and then log base 5 of negative 2x. That negative 2x is the whole argument, so I can't break it apart. So I'm going to go straight to exponent form. So 5 to the x equals negative 2. Oh, that should be a y, sorry. Now I'm going to divide by negative 2, and I'm going to get negative 5 over 2 to the x power equals y. So now we just have a few more steps. I have x equals log base 2 of y minus 1 plus 6. So I'm going to subtract that 6 first. Now my log and argument are isolated, so I'm going to go to exponent form. So the base of 2 raised up to the x minus 6 equals y minus 1. Now I'm going to add that 1, and remember it doesn't change anything, just it's now my horizontal asymptote. Okay, and so now x equals 2 log base 6 of x plus 2 minus 7. So remember the parts that we are isolating is the log to the argument. So I don't need to worry about the other stuff. I need to get rid of it and move it to the other side. So I'm first going to add that 7. Now I'm going to divide by 2 or multiply by the reciprocal. I'm going to choose to multiply by the reciprocal. And yep, I did it again. These should be y's. You can see what my issues are. Now I'm going to go into exponent form. So 6 raised up to the 1/2 x plus 7 equals y plus 2. And now I'm going to subtract that 2. And there's my inverse. Okay, now we're going to start with exponents, and we're going to go to log. Same exact thing. Where y is, I'm going to put an x. And where x is, I'm going to put a y. I've got to isolate by dividing by negative 1. So negative x equals 2 y minus 3. Now we're going to go to logarithmic form. So log base 2 of negative x equals y minus 3. And now I'm going to bring that 3 over by addition, but notice my argument stays in parentheses and that value on the outside. So that it shifted up 3, but my asymptote's at 0. So you got to remember that once the argument is rewritten, it doesn't change in there. Okay, here's another exponent. Where y is, I put an x, and where x is, I put a y. I've got to isolate that base and exponent, so I'm going to add that 4 to both sides. X plus 4 equals 10 y over 2. I'm going to go to logarithmic form, so log of base 10, I don't have to write it, it's understood, of x plus 4 equals y over 2. Now I'm going to multiply both sides by 2, and I just put that in the front, and there's my inverse. And now x is negative 1/2. The basis for x plus 9 minus 3. So I've got to get my power, which is the 4 to the x plus 9, which should be y plus 9. I'm going to add that 3. Now I'm going to multiply by the reciprocal or divide by 1/2, whichever. I'm going to multiply by this reciprocal, which is negative 2, x plus 3 equals 4 to the y plus 9. Now let's go log. So log base 4, negative 2, x plus 3 is the argument, equals y plus 9. And now I'm going to subtract that 9, so log base 4, negative 2, x plus 3, minus 9 equals y. And there's my inverse. Okay, last 3. Where y is, I put an x. And where x is, I'm going to put a y. I'm going to subtract that 2. I'm going to move into logarithmic form. So log base 6 of x minus 2 equals y plus 1. Now to isolate that y, I'm going to subtract 1. It doesn't change my argument any, so it's going to be on the outside. Okay, this next one, where y is, I put x, 2, base of 3, x minus 6, plus 4. So I'm going to subtract that 4. I'm going to divide by 2 or multiply by the reciprocal. As you know, I like to multiply by the reciprocal. Now we're going to go to logarithmic form. So log base 3 of 1/2 x minus 4 equals y minus 6. See, I did it again. When I get that point, I know I've done it wrong. Sorry about that. And then log base 3 of 1/2 x minus 4 plus 6 is y. And now the last one. I see I have a base of e. Remember, e is a number, so I'm going to go to natural log. So x equals 5e, y plus 4 minus 10. I'm going to add that 10 first. I'm going to multiply by the reciprocal. Now we're going to go to logarithmic form. So e is the natural log of 1/5 x plus 10 equals y plus 4. And now I'm going to subtract that 4. And there is my inverse. And that is how you inverse.